All right, we are now in chapter 6. This is the last chapter in Math 230. So 6.1 is functions of several variables. This is actually something that you would see if you were taking a Calculus 3 course. You would actually get into functions of multiple variables. That's why they call it multivariable calculus. We will get into some of the topics there. We will not get quite as in depth as they do in Calc 3, but you are going to start seeing some multivariable calculus. Okay, so let's go ahead and get started. Our objectives are to find a function value for a function of several variables, solve applied problems involving functions of several variables, and our vocabulary is obviously function of several variables or multivariable. Okay, this will actually seem like, at least I hope, of these last few sections, this will seem relatively easy. It's more of a concept that you have to understand because the math here is actually very simple. The next couple sections will involve some calculus that will get much more challenging. All right, so you should probably be able to think of a situation where one variable model just won't be enough. One of the examples that we're going to give, and I'll give a couple that, or at least one more that's not even on here. But for our first example here, Sunny Press, a small publisher of children's books, is currently selling two different children's books. One of them sells for $4 per book, the other one sells for $6 per book. Its revenue function, R, needs to incorporate information about both independent sales of both books. So if Sunny Press sells X copies of the first book and Y copies of the second book, then the revenue is going to be a function of both X and Y. So it's R of and then X comma Y. That's not R times a point or something like that. It's R of X and Y. So now just instead of f of X, it's something of and then two different variables, where the function is given as 4X plus 6Y because it was $4 for the X books, $6 for the Y books. So the function takes each independent pair, X and Y, and assigns it to exactly one output. If Sunny Press sells 22 copies of the first book and 17 copies of the second book, then your desired input is the point 22 comma 17, and then you would just plug 22 and 17 in for X and Y respectively, and you would end up with $190 revenue. Okay, again, it's not really that difficult. You just have to make sure you're plugging the right stuff in for the variables. Again, it's more of a concept thing, more interested in your understanding what it actually means at this point. So example number 1. Large purchases are often financed with an amortized loan in which the borrower's payments go towards the principal or the amount borrowed and the interest. Borrowers, tough word to say, like to know how much they can expect to pay per month for each $1,000 borrowed. The monthly payment, P, depends on the annual percentage rate, or the APR, and we just use a little r for that one, and the term of the loan, which is T, in years. And then the function is a function where the monthly payments depend upon both the interest rate and the amount of years. So the P of RT. And it's given by this crazy looking function down here. How much per month can a borrower expect to pay per $1,000 borrowed at an APR of 4.5% for a 6-year term? Well, that means what we're trying to find is P of, and let's see, what's the rate first? So we're going to write that as not 4.5%, but 0.045. Make that look like a 5 instead of a 15. And 6-year term, so 6. So we want P of 0.05 comma 6. So let's go ahead and plug everything in, and we're going to use a calculator to figure out the value. So let's see, we get 1,000 times the interest rate, 0.045, times 1 plus R, which is 6, over 12, raised to the 12 times 6 power, because T is 6, all over 12 times 1 plus 6 over 12, 12 times 6 is the exponent, minus 12. And don't worry, obviously there's no reason you would need to memorize this. You would have this available to you. And then we're just going to plug this thing in and see what we get when we put in the calculator. And while most of the time the numbers will not work out quite this nice, this one works out to be 3.75. And so the answer is, what is that? Well, it's $3.75 thousand. That doesn't make any sense. I guess it does. $3.75 thousand. Okay, so $3,750 per month. I don't know if this is a mortgage, but this is what it sounds like. That's a really high mortgage if you ask me. Anyway, that's what you would expect to pay per month. One other example, and I'm going to do this one before we go into the next example. One thing that's really easy to think about is, if you think about a very common thing like weather that we use every day, weather depends really on a couple of different things. It actually depends on more than two things, but the two easiest things are, if you're thinking about like when it's cold, you always hear about, oh, well, the real temperature outside is 32 degrees, but the wind chill temperature is, 20 degrees. Well, that's because you have to take into effect the actual temperature outside. That's one variable, and the second variable is the wind chill, so it affects the temperature as well, or what it feels like anyway. So that's one thing that you can think about, is where you've got multiple variables. Also works in the summertime when you're talking about the actual heat outside, and then the humidity, which raises the heat index. Just a couple more examples there. All right, number 2. The total cost to Bradshaw Steel in hundreds of dollars for producing a spool of rolled steel is given by this function. It's C of x, y, z, and w. So C is a function of 4 variables. And it's 4x squared plus 5y plus z minus the natural log of w plus 1, where x dollars are spent for labor, y dollars for raw materials, z is for advertising, and w dollars is for machinery. It's a function of 4 variables, all in thousands of dollars. We just want to find C of 32110. Again, biggest thing is just make sure you're plugging in the number for the correct variable. So in this case, because it's already on there, this is x, this is y, this is z, and this is w. So just make sure we plug it in the right way. So C of 32110 is going to be 4 times 3 squared plus 5 times 2 plus 1 minus the natural log of 10 plus 1. So it looks like what we're going to get here is, see, that's 4 times 9, which is 36, plus 10 minus 1, plus 1 minus the natural log of 11. So it looks like we're going to get 4647 minus the natural log of 11. So that's our total cost. What is it? I don't know. We're going to have to plug this into a calculator to get somewhat of an actual, we want to get a decimal approximation here because we're dealing with money. So let's do something that actually makes sense. Let's plug in the calculator. And that works out to be about $44.60 as an approximation. All right, not too difficult to plug the numbers in. Just be careful when you plug the stuff in your calculator, especially like, for example, 1. Make sure you're really careful with that, plugging that stuff into your calculator. Okay, the geometric interpretations are actually kind of cool. So visually, a single variable function, y equals f of x, can be represented by a line, and I actually don't even like to use the word line there. I'm going to use the word curve, because it's going to look something like what you see here, or it could look something like you see there, depicting a height above the x-axis. So when you're talking about y equals f of x, the y value is the height above the x-axis, and then the x value tells you where you go on the x-axis to go up to that height. So the y basically represents the height above the x-axis. When we want to visualize a 2-variable function, f of xy, we first imagine laying the xy plane flat on the ground. So here's the xy plane. So here's your x-axis. Here's your y-axis. It's almost like you're laying it flat on the ground. And then what you've got is you've got all this space down here, which is the XY plane. What you want to do is you kind of want to imagine like a corner of a room and the floor being the XY plane. So instead of like looking at it flat up against the wall, the floor part is now the XY plane. And then the part that goes up the wall, that corner piece that goes up the wall, that's the Z-axis, that's the vertical piece. That's what's new in a three-dimensional or two-variable graph. So it basically becomes a three-dimensional drawing. Obviously, these things can get very, very challenging. Some three-dimensional drawings are not too difficult. A lot of people can very easily see in the example that we gave here, like this box, that's not too difficult for most people to understand how to look at. But there's going to be some things here that we're really going to have a difficult time trying to see. So there's our box in the green there. The Z-axis goes vertical, and the X and the Y, like I said, it's like it's laid down flat. So you're going to have to get used to seeing it in that form. So you can use programs, and this is the good thing, because obviously I'm not going to have you guys sketch these things by hand. But you can use programs. There's one called Wolfram Alpha. I am actually partial to one that's called CalcPlot 3D. I'll write that down here. It's called CalcPlot 3D. That's the one that I'm going to use to show you guys some visuals. But Wolfram Alpha is usually pretty easy for most people to use, so that's why we tell people to go to that one. If you go to Wolfram Alpha and you plot the graph z equals 4x plus 6y, and you can practice that, you're going to get something that looks like this. It's basically just a plane. It's a plane which is raised, as you can see, off of the XY plane. It's not exactly the same as the XY plane. It's raised. It's got an angle to it. Kind of a boring one, but at least it's still something to get you started with. Now you can use Wolfram Alpha to sketch these next ones. I am going to do them with you guys on CalcPlot 3D. I just think it's easier to deal with. So the first one, f of xy equals x squared plus y squared. So f of xy basically is another way of saying z in this case, but it is a function of f of xy, but you can call it z as well. F of xy equals x squared plus y squared. Let's take a look at that first, and then we're going to see how to describe it. All right, so as promised, here is my CalcPlot 3D. I'm going to go ahead and open up x squared plus y squared, which is the bottom one here on the left. And there it is. That is the graph of f of xy equals x squared plus y squared. Now, it's not real interesting to look at in this form, so I'm going to actually move it so we can tilt it. So if you kind of tilt it this way, now it gives it some dimension. Kind of just looks like some kind of a bowl, like an open bowl or something like that. Not exactly something that's going to stand up for us, but that's what it is. It's a bowl. And then you can also take and rotate it, like left and right. See if I can do that. And you can just see that from any side, it looks exactly the same. This is actually what's known as an elliptic paraboloid. It's called an elliptic paraboloid because of the fact that if I turn this down, the top of this thing is actually, well, this one's actually a circle, but it could be an ellipse. So if you were to trace around here, that thing right there looks like it's a circle, but it could also be wider and look like an ellipse. And then the sides here, if I go down from here all the way down to the bottom and then back up the other side of this thing, those are all parabolas, and it's the same thing in this direction as well. Those are all parabolas. So it's called an elliptic paraboloid. So let's go back to our other page, and we'll sketch this. Notice, by the way, that this one here starts basically at the origin and then opens up. So when I go to sketch this on our graph, we can sketch it real quick. The first thing you need to do is sketch yourself an XYZ plane. So I always do the vertical part first, and then I do the x-axis and then the y-axis like this, x, y, z. And then to sketch the elliptic paraboloid that we have on the last one, I just kind of draw myself a little bowl looking thing like this, or just draw a parabola. And then I finish the top by making it look like that. Again, really rough sketch. I am not an artist, but at least it is a sketch of what we did. Okay, part B. G of xy is equal to the square root of 1 minus x squared minus y squared. And again, I've already plugged this stuff in. So we're going to go ahead and take a look at it. Let's get rid of this one. And this one right here is the square root of 1 minus x squared minus y squared. And there it is. Kind of hard to see. It's a little bit smaller. But again, if we kind of take a look at this thing from different angles, it's hollowed out on the inside. Kind of looks like half of a ball. And that's exactly what it is, actually. It is half of a sphere. If I was to do the negative of that same exact square root, it would finish off the bottom of this sphere right here, and it would be a whole sphere. So that's what this one looks like. It looks like the top half of a sphere. Specifically, it's got a a z-intercept here of 1, a y-intercept of 1, an x-intercept of 1. That's because it's the same all the way around. So this thing is basically a hemisphere, half of a sphere. So let's go back and draw that one. So again, I'll do my z-axis, x-axis, y-axis, x, y, z. And I know that this thing goes out to 1 on the top. It's going to come down here to 1. It's going to come down here to 1. And then it's going to be somewhat circular in this fashion. And again, this is a really rough sketch of this. Try and make that a little bit better right there. Let's see. There we go. All right, so there is our hemisphere. Again, you don't necessarily need to know the name of these things. Just know how to plug this stuff into an online calculator type of thing, like Wolfram Alpha. All right, last one, and then we'll take a look, and that's actually the last part of this video. So let's take a look at x squared plus y squared plus 1 over x squared plus y squared. So it looks very similar to A. We've just added this extra 1 over x squared plus y squared. This is actually a really cool one. And that's this top one right here. There you go. And you might think, oh, it doesn't really look all that cool. Well, just wait. Right now, it actually kind of looks like the first one did, except that without the bottom piece coming all the way down here. It looks like that elliptic paraboloid. But now let's take a look inside. There you go. I don't know. It looks kind of like one of those, where they make a bundt cake or something like that out of things like this. One of those type of pans. Anyway, there you go. So it definitely has a different, interesting look to it. So it looks kind of like the first one, but it's got that little inside piece there, which is hollowed out, but it also comes back up. Very interesting. Not easy to sketch that one. We're going to try. Let's see how good I can do on this. And again, remember, it's just a sketch. So don't freak out if it's not perfect, because it certainly is not going to be, at least not in my case. So I'm going to go ahead and try and draw this piece kind of hollowed out, coming around like that. And then the inside has another piece like that, and then it kind of tends to go down like that. Well, actually, that's not bad. It's not great, but it's not bad. Anyway, there you go. There are your sketches. Again, mostly it's just going to be recognizing not necessarily the shapes, but what the actual real life application is and being able to plug the numbers in correctly. All right, that is all for this section.